let's get set up and started on our final project, number 3, rainfall simulation in processing, worth 100 points. So let's take a look at the specifications for this. Project 3. So you're going to create an animated simulation of rainfall on a background scene of your choice. Here are a couple of scene examples, and we have a base file. It's not actually here. This gives you a 404 error, but I'll show you where we can find that. Now, we did a tutorial on how to load images into your processing programs, and so that is something we have covered. Nonetheless, I would like to search my database. I searched on the internet for a nature scene of some sort, and in a JPEG extension. So any of these that you can find out here that you want to use, make sure you're thinking a little bit about copyright infringements and whatnot. But you can save one of these, download that image, and you can use that as we explained in our loading images tutorial. So we're going to go back in here. Now this random circles array, if we pull up that hyperlink, it takes us to a 404 error, not found. So I'll show you where we can actually get our base file to begin our processing, our final project. So if we go into assignments, under home, down here you're going to see processing examples, and we are looking for random circle array. Random circle array. We're going to copy and paste this into our processing program and see what it does. And we're going to break that down, but let's take a look at the output. Get us excited about this code. So right here, what we're seeing is the beginning of our rainfall simulation. These kind of look sort of like rain is falling. So let's go through our code and see how it produces this image. Okay, we have declared some variables, an X and a Y, a D, which is going to be for diameter, and a shift, which we could use for to shift your, we haven't used that in here. So right here, we can shift the value of X over so that the raindrops don't fall on a single line, that they shift over along the X axis. So that's going to provide us that shift. We're now declaring a variable called numCircles that has a value of 2000. This will be referenced here again. So now we have 3 arrays that we're working with. We have an integer array called our X array, and it is a new integer array of numCircles, which is 2000. So in a sense, that is just saying we have 2000. We have declared an array that will hold 2,000 different elements in it. All right, at this point in time, not elements, integers. We have a float Y array. This again, a float is the possibility of, well, it does hold values on the right-hand side of your decimal point. So they do have decimals, partial numbers, and floats. So we have our Y array. It is a new float array of 2,000 float elements. Same thing with speed. This is another array that we're going to be using, and it has allocated 2,000 elements in there, float elements available. Going through our setup, our window size is 1200 by 800. We have a background of black, and we go into our for loop. Starting off at 0, we're looking at our X array dot length. So this is going to go, that would be 2,000. And each time we go through I, we're going to do these items here, and then we're going to add 1 to I. So first time through, I is 0. So we are referencing the 0 index of our X array, and what we're putting in that 0 index is going to be the value of X plus I times shift. So if we look at what that might be, we have X is going to be 75 plus I, which at this point in time is 0, times shift. Shift is 2. So if we were to look at that, doing order of operations, 0 times 2 is 0 plus 75, so that's going to equal 75. That's our first time through. Now our next time through, I becomes 1. So now we have x, which is 75, plus I, which is 1, times our shift, which is 2. So now we have a value of 1 times 2 is 2 plus 75, that is 77. So that's the second. At index 0, our value is 75. At index 1, it's 77. Let's see what index 2 would look like. We have now I is going to be 2, so we have 75 plus I times shift, and that equals 79. So you can see how this is a pattern. So in our X array, we're going to start off with our value X coordinate that we're going to be using to place these random circles. It's going to start off at 75, it's going to go to 77, 79, etc. Let's look at our Y array. Now this is how you can do a random call. What we're going to be doing is a range. We're going to have random numbers fall within a range. Here is the beginning of our range and here is the end of our range. So in other words, we have a random call of Y minus 10. We have, which is, if we reference that, 60 minus 10 is 50, up to Y plus 11. So that's 60 plus 11. That's going to be 71. So our Y's will be randomly assigned a value between 50 and 71. So at index 0, it's going to pick a number between 50 and 71 through a random generator, and it's going to assign that Y array at index 0 some random value between 50 and 71. Next time through, it's going to go through. I is going to increment. We're going to come down in here, and I is not involved in this line of code other than just telling us what index we are referencing on our Y array. So now I is 1. So now we're in referencing the Y array index 1. We're going to assign another value somewhere between 50 and 71. When I becomes 2, we're referencing a new index, and we're providing a new random value. Same thing going from speed here. We are having at index 0 some random value between 7.9 and 19.1. At index 1, again, another value between 7.9 and 19.1. As we go through that, those arrays are assigning values. So an X array at index 0 is going to have a value. Y array at index 0 is going to have a value. And speed array at index 0 is going to have some sort of value. Okay, that's what we're going to be doing. And we have 2,000 elements in these arrays. Now we're going to draw. So again, we start off with our background being black. We're going to go into our for loop, starting off at index 0. Assigning a value for I, integer I, 0. 0 being less than array.length, the X array, which we have 2,000 of those. So 0 is definitely not anywhere greater than 2,000. It is less than that. So we're going to go through this for loop based upon this X array.length, which we have here as being 2,000. So this for loop is basically saying I equals 0, I is less than 2,000. We're going to do something inside our brackets and then add 1 to I. So we're going to go through this for loop 2,000 times. Every time we go through that loop, we're going to draw an ellipse. At index, we're going to have the X value referencing the array, the X array at index 0. So that index I is 0, I is 0. Y, we're referencing the Y array at index 0. And then we are hard coding in a diameter of 5 for our ellipses. Now we have our Y array, which is our horizontal movement. We are taking in some random value for speed and some random position for Y. We're combining those and then we're putting them into our Y array. As we look here, Y array at index 0 was filled in up here. So Y array at index 0, it's going to be some value between 50 and 71. Speed is going to be some value between 7.9 and 19.1. And we're going to add those two together. And then we're going to put that in place of the Y array's value at 0. So we're changing this Y array right here by substituting what it was before to what we get when we do those calculations. Now, we have a new value here for Y array. If that value is greater than the height of our window plus half the diameter, we're going to say that Y array at I has a new value, which is a negative diameter divided by 2. If we think about this, our diameter is 5, divided by 2 is 2.5. A negative 2.5 is going to be above our window. So it is replacing that ellipse back to the top of our window. So it can refall again. And when it gets to the height, which is at the bottom, plus 2.5 so that it gets off the window, we're going to reset it to the top by changing that value right there. So as we go through this, let's watch this again one more time. And they are falling. Now they are falling and falling and falling and falling. You might see, as you can note, some are falling faster than others. That has to do with our random speed value that we have here. We are seeing that they're not all falling at the same point. That has to do with how our X array is instantiated. And you can see if they come to the bottom, then they go back to the top. So they keep going. To demonstrate how this reset of those raindrops look, let's just take this if statement out. And if we run this, we are just going to see that the raindrops go off the screen but never come back. So that's how we are resetting those Y values so that we can reuse those raindrops again and again. So this is your base file. Let's go back to our specs and see what they have for us to look at. Now, let's put in a picture. I have, let's put in a picture to see how that looks. We do need to, we'll get to that. So feature specifications. We need to change the screen size to 1200 by 800. Okay, 1200 by 800. So we are good. We need to create a classic raindrop shape using basic shapes. This example here, I'm going to provide you as an attachment so we can see what that looks like. This is the code for that we were referencing here on the website provided on Piazza. So this is that code, and you will be provided a copy of this in as an attachment to this email. You can just copy and paste this in. Let's see what this code here does. So it produces some arcs and what actually looks like a decent raindrop there. Let's take a look at how we can create that raindrop. It says here that we might want to be, the simplest way is to put a triangle on top of a semicircle using the arc function. So if I were to comment out these lines of code, I have this arc and this triangle is going to be right on top of that. So you can just see that the X, the shift for this triangle is just a little bit above the x value here because we have a value for x being 75. So that arc is being drawn at its x coordinate is 75. This triangle's coordinate is going to be 75 minus diameter divided by 4, so that's 5. So that's going to be 70. So this x coordinate for this triangle is 70. This arc is 75. So you can see how there is just a slight difference. This triangle will be on top of this arc. You can see that there coming along. We'll leave that one there. So there we have it. Classic raindrop shape. So again, this code I will provide for you so that you have the ability to use an arc and a triangle, and you can use this in your project. The raindrops should be of random sizes. Okay, well, let's look at our code real quick. We don't have anything up here for a random value of diameter. So you're probably needing to, we have a value that we can use for diameter of 5 if you wanted to, but that's not going to be randomized. So what we would need to do then is to set up a new array. Sorry. Set up a new array, a new float array for our diameter. This is because each different raindrop has a potentiality to have various sizes. So you'll need to look at something that it'll probably be a new float, and we just need to declare that in the beginning. So now we will have a way to house the diameters for each individual circle as they are being generated. Now down here, you can see that we have, we are filling our array. This is where we're putting information into our array. At index 0, we're putting an x coordinate. At index 0, we're putting a random y value. At index 0, we're putting a random speed value. Well, this would be a good place to put in your diameter, make it have some ability to get your diameter. Maybe it might look kind of like diameter at I equals some random value. And we don't want to make these huge or very, very small. I would say no bigger than 10, but no smaller than 3. So maybe 3 to 9, something like that will give us a random size. But this, again, this diameter here has not been instated. It says here, this type of expression must, it's not resolved yet. We need to go up here at some point and set up our array so that we have the ability to fill our diameters at each index of our array. So that could get you started on those random sizes. Animate those falling to the ground. Well, right now we have these ellipses are being drawn here to do that. That's great, but we also need to be putting a triangle on top of those. And we're going to be accessing a random diameter, not a random. Well, yeah, it will be randomized, but it will be accessed at the index of that diameter array. So this is just when I have that variable d, it's going up here and grabbing that value 5. So these are hard-coded, and all of our raindrops will be of diameter 5. And we don't want that. We want the diameters to vary on our raindrops. So this will need to be adjusted to set up for those the different size diameters. All right. Let's add our nature scene in here. It did mention somewhere along this right here is pretty important. This surface.setResizable to true. We need to put this in our setup function. I'm going to copy that We're going to move over into our setup function right under our window size right here. I'm going to put that in there. So we're good with that. I missed that a couple times and it doesn't work. So this will make your sketch resizable. So I can change the size of my window. In fact, let's maybe test that at this point. It does say test it, so give it a shot. Let's see what we got here. I do have to comment this out because I haven't made my array yet, and that will cause an error. Okay, so here's my window. Works pretty good. I'm wondering if I can resize it on the fly. Okay, see, there it goes. And now as I get closer here, so it is resizable. We can see we can pack in a bunch of elements in that small area. And we have more space out at this point when we stretch out our window. Okay, so we need to talk about putting in our background. Let's do that. We've done a couple examples so far, so should be relatively easy. We will need to save this into a folder. We need to save an image into a data folder next to our processing source code. Let me set that up and show you what that looks like. I've saved this as a P3 setup, project 3 setup. I have it saved in a folder, and I created a data folder, and I imported my nature scene, JPEG nature scene. Okay, so this is important that we know exactly how it is identified in there. So what we want to do now is in our global variables up here, we're going to start off with our P image variable, and we're going to just store and name it image, img. So it is of type P image, and it is named image. So then when we go down to our void draw, down here we have our background being black. We now need to go and put in our image here, img, referencing this variable here, and we're going to put it at 0, 0. In our setup, we will need to now load that image into that variable image, so img. So under setup, underneath our surface resizable, let's put in our, let's assign a value. We're instantiating now a value to image, load image, and in quotations, exactly as you see it in your folder. Now let's take a look and see what we have here. Okay, so now we have these random ellipses falling on a nature background. Pretty cool. Okay, so that part we're doing well on. So let's take a look at our specs. Magic wand. This is something that you're going to be working on here. You will be able to use a Boolean variable to toggle on and off. So if mouse pressed, then do this. If mouse released, do something separate. So let me give you an example real quick where you can find something to help with that mouse pressed feature. Here is some code that I've shared with my students before to help a little bit understand how that mouse press feature might work and how you can use a Boolean to like an if statement to toggle on whether or not that in this particular case, like a tennis ball, is moving. So what we have here, and I will provide this code for you, mouse moving ellipse with mouse press and functions. Okay, this is gonna be very handy for your project. Right here, I've created a function moving ellipse. Now that function basically will draw That's everything from there to there. So when I call my void draw method, all I'm doing is calling one function. That's it, that's in my draw method. So I have a function declared here, moving ellipse. Its scope is from there to there, and inside that, a lot of good things are happening here. So let's take a look at what the result is, and we can explain how that works. I have here what it's kind of like a tennis ball, moving back and forth. And as I hit my mouse button, I stop and start that movement of that tennis ball. So if we look back at our specs, our magic wand, pressing the mouse starts the rain, pressing the mouse again stops the rain, and so on. So this could be good. We should probably take a look at what is going on here. All right, I have created a variable in my setup called state. I'm saying that I've declared it globally, and I have initialized it to have a negative value. So when we start off, state is a -1. If that state is a -1 right here, so which it is, we started off at a -1, then we're going to draw our background, we're going to resize it, we're going to put that image in there. I don't have it loaded right. And we're going to move, we're going to create a movement here with a direction and a speed. So right now direction is 1 and speed is 1. So we are moving in a positive value. So movement is equal to speed times direction. So right now 1 times 1. So movement is a positive 1. So and that updates every time we go through this moving ellipse function. So that gets updated as it goes. So right now it's 1 times 1 is move, and then it will update the next time through is going to be 2, and then 3, and then 4, and then 5, as I believe as this sort of increments it back there. Now, if move becomes larger than the width of the window minus the size of our tennis ball, or if move is less than the size of our tennis ball, the radius of our tennis ball, just half of that, then we're going to toggle direction back and forth. Direction is going to be, if it's negative, then we will make it positive, and if it's positive, then we'll make it negative, and then I do have a print line here to tell me what move's value is. So if that happens, that means that it reverses the ellipse, else we are going to say that direction is 1, and we're going to move the ellipse forward or to the right. And now then, if state is 0, so we start off with state being a -1. This is my void mouse press method, toggles on and off the animation. If state is actually a -1, when I hit my mouse press, state changes to 0, else it's also back, else it goes back to -1. So starting off at -1, when my mouse is pressed, I change the value of state to 0, and then if it's 0, then I change it to -1 by using that mouse pressed feature. So again, one more time as we're going through this. Toggling between state of -1 and 0 as it goes through this code. This will be provided, and it can be very handy to help you out with your project. Functions. So as you saw, I gave you kind of an idea of how to create a function. And our arrays, that is where we are. We have been working with that extensively, and your project already has some built-in arrays, but we do need to remember we probably are going to need to have a float array for our diameter. And one piece of one suggestion possibly as we go through here and we look at this, this animation of the raindrops falling to the ground, smaller raindrops should fall slower than larger raindrops. Okay, so the larger the raindrop, the faster it should move. The larger the raindrop, the faster it should fall to the ground. So one piece that might be kind of confusing is this setting up of our speed to be a random value. Speed is, in this particular example, speed is based on the size of our diameter. So if we have a value for diameter, which is randomly assigned, we will have a random assignment here of our diameter. If you think about it, if I just had a somewhat of a constant for speed, say maybe it's 2, and my diameter randomly came up to say 3. So if I have 3 times my speed of 2, that will fall at a rate of 6. Now, if that happened to make a larger diameter, 9, and my speed was still just a value maybe of like say 2, well then 2 times 9 is 18. So you can see that it's falling much faster than the smaller diameters. So be aware that this may be confusing, and you might want to try to just manipulate speed based on the diameter of your raindrop. All right, so extra credit. Oh, wait, well, actually, so for this assignment, well-documented sketch means having well-named components, variables, and functions, so I know what I'm referring to if I look at these things. Here we go, extra credit. Have the raindrops splatter when they hit the ground. Okay, there could be some sort of a burst of that raindrop. We could have extra credit of having raindrop collect in puddles on the ground. You could have some sort of water level increasing. And we're already putting raindrops shapes somewhat into our sketch. Here is your write-up. In your portfolio, you want to do a write-up here. Title of the sketch. Just describe it in 1 or 2 sentences. Include an interesting screenshot. Include a brief explanation of the various functions and the parts of the code. Use code snippets to highlight these things. Include a video showing your sketch in action. The video should be short, less than a minute. And then include your project, your processing file into your portfolio. If you want to download it, you can, but I will need to see, you can download or you can just copy and paste the code into a segment in your portfolio, but I will need access to your image so I can see that you place that into the back. So I can put that in a folder on my own side here and run your program accessing that image that you're wanting. Here's your rubric. We have 10 points for the raindrop shape, 10 points for random raindrop sizes, 10 points for variation of speed based on the size of the raindrop. You get 10 points for putting that nature background in, 20 points for the quality of your rainfall animation so it looks and runs smoothly. The sketch resizes appropriately. We have our magic wand working. You're using functions. You have a video that you're going to help support your presentation with, and the basic documentation and code style. If we want to do extra credit, we have discussed those there. And this is all going to be turned into your portfolio under your project. And get started early on this. So if you have questions, you can get a hold of me.